G'day. What we're going to do today is do a really simplistic way of looking at clearance, because I know a lot of people have difficulty with it. So here we have our nephron. Here's our Bowman's capsule. Here's the end of the nephron, the collecting duct, and we can say that these nephrons will, of course, go to the ureter and to the bladder. Now, what I'm going to do is I'm going to link it all to excretion, because I think that can really help in your understanding. So let's look at the excretion of a substance. So let's call it substance X, okay? Now, what we can say is substance X, we can measure in the urine that the concentration of substance X in the urine, we measure it, and the concentration of substance X is equal to 100 milligrams per mil. Then we can look at the urine flow rate and the volume or the flow of the urine in mil per minute. We can say, let's make it nice and easy, equals 1 mil per minute. So from this we can calculate the excretion. The excretion of X, how much is being excretion? The excretion rate is simply the concentration in the urine multiplied by the urine flow rate. So in this case it's 100 milligrams per mil multiplied by 1 mil per minute. So therefore what we've done is we've excreted 100, cross out the mils, milligrams of substance X every minute. So what is its clearance? Well, clearance, as we know, is the volume per unit time that has had substance X completely removed from it. So the volume of plasma per unit time that has had substance X completely removed from it. Well, that really doesn't mean anything to us until we know one particular value. What is the concentration of X in the plasma? Okay. So let's have a look. Let's think, okay, well, let's say that the concentration of X in the plasma, which we easily can measure, let's say the concentration of X equals 1 milligram per mil. So therefore, in every mil of plasma, you have 1 milligram of X. Now we know the formula for clearance. The clearance of X is equal to the excretion of X, which is the concentration of X in the urine, multiplied by the flow of urine over the plasma concentration of X. So if we use this formula and look at this diagram now, what you can see is the clearance of X is equal to 100 milligrams per minute, because we've calculated excretion here, over the concentration of X in the plasma, which is 1 milligram per mil, which, cross out the milligrams, the clearance of X equals 100 mils per minute. But that's fine, we can do that, we can get the answer to it. But what does it actually mean? Well, it means, of course, if you can see here, if we excrete 100 milligrams of X per minute, and we get 1 milligram of X for every mil of plasma, it means that you need 100 mils of plasma to give you 100 milligrams of X. And if you've got to have that 100 milligrams every minute, then you need 100 mils of plasma every minute in order to do that. So therefore, you have cleared 100 mils of plasma totally of X. What would that look like? Well, I'm going to tell you something that you might not know, but I'm going to tell you that normally you have maybe between 600 to 700 mils of plasma passing by the glomerulus. Let's make it 700 mils. So this is all the plasma, okay, that is passing by the glomerulus in 1 minute. Now let's look. Here's X, nicely sprinkled all around in that plasma at 1 milligram per mil. Well, what the clearance value means of 100 mils per minute, it means that out of this 700 mils that passes by the glomerulus every minute, you have taken 100 mils of that and cleared it totally out of here of substance X. That's what you've done. And that's what clearance means. It's a totally hypothetical value. It's a hypothetical value, yeah? But it helps you understand how much you're actually removing. So what we've done is we need 100 mils of plasma to give us this excretion. I hope that helps you with clearance.